Hello, my name is Dalton Aringa, and I'm attending Engineering 120 during the fall semester at NMSU. The purpose of this video will be to learn the inner workings of the breadboard and measure the resistance of a resistor with a multimeter from different slots. For the purpose of measuring resistance, we are going to be using a multimeter, which will be configured to measuring ohms, which is the unit for resistance in a wire. The breadboard lives true to its name. It has tiny pores or holes on the surface. Its rows are labeled horizontally using alphabetical letters A through J, while its columns are labeled with numerical values ranging from 1 to 63. The breadboard is only internally wired vertically for the middle section, so these two rows. So the resistance of a wire can only be measured by placing the measuring wires vertically to each other, therefore creating a short circuit that will measure the resistance of the wire. The special rows, the top and bottommost, have wires running horizontally through them, unlike the middle sections which have wires running vertically through them. To measure the resistance of the resistor connected to the breadboard, I'll be using an orange wire, which will represent red, and a brown wire, which will represent black, to connect to the multimeter wires, which will be connected to the positive and negative terminals of the multimeter. As you can see, the measured value of resistance of the resistor on the breadboard is 5.04 kilo ohms. Let's try our more scenarios with the resistor still in the same spot. For the second scenario, I will insert the orange wire into column 40, row E, and the brown wire into column 40, row A. This will create a short circuit that connects the internal wires along column 40 and bypasses the resistor, creating a short circuit. The ideal resistance of a wire or a direct connection of a wire is 0. As you can see, the value that is recorded on the multimeter is 0. For the third scenario, I will insert the orange wire into column 20 and the brown wire into column 45, row B, and measure the resistance. The resistance becomes 0 or blank mega ohms because the resistance is too large to be measured by the multimeter. The resistance is also 0 mega ohms or blank mega ohms because there are no internal wires connecting the rows internally or horizontally. The highest reading that can be measured by this multimeter will be 20 mega ohms. This scenario demonstrates a break in the circuit or an open circuit that does not have the positive and negative terminals connecting. For the next two measurements, I'm going to be using the topmost section, which has internal wires connecting the poles horizontally instead of vertically. I'll place the orange and brown wire in the first row and measure the resistance. As you can see, the resistance measured is 0 ohms, denoting that there is a short circuit because the wires internally run horizontally, so connecting the wires directly to each other. For the last scenario, I'll be connecting the orange wire to the top row while I connect the brown wire to the bottom row. The multimeter displays a value of 0 mega ohms because there's a break in the circuit since the internal wires connect horizontally rather than vertically, and the sections are in different, and the wires are in different rows instead of the same row. Thank you for watching the video. That is all for now. I hope you learned the layout of the breadboard and how the internal wires connect to each other in different sections. I also hope you learned how to measure the resistances of the resistance in different layouts and different scenarios on the breadboard. Goodbye.